Okay, here's another acceleration related problem. Again, I'd like you to list what you know and what you don't know. Reading the question, what time, so we need to find out the time. What time is required for a golf cart to increase velocity from 5.08 to 8.33 kilometers per hour north at an acceleration of 1.17 times 10 to the third kilometers per hour squared. So our initial velocity is from this amount, 5.08, north. Final velocity, 8.33, again north. And the acceleration is 1.17 times 10 to the third. Now, if you haven't done scientific notation yet, check out my scientific notation video. But just quickly, this is going to be 1.17, and this times 10 to the 3 is like saying I'm going to multiply this thing by 10 3 times. So, and what that does is it moves the decimal point. So it moves it from here to here once, twice, and 3 times. The decimal point is going to land right here, and we put in a 0 here for a space holder. So the acceleration really is 1170 kilometers per hour squared. Okay, and that's again in the north direction, so we have acceleration all in the same direction. Okay, so next we need our acceleration formula, which is A is equal to Vf minus Vi all over T. So this formula here will be given to you on tests, but I'm not going to rearrange it for you, so you need to know how to rearrange these things. Okay, so to have this one solved for T, if you can remember that these two guys can just swap positions, great, but I'm going to just show you the math behind it. So bear with me here. We've got multiplying both sides by T to clear out that denominator, so leaving us with AT is equal to Vf minus Vi. Now we want to get the T over here by itself. So right now it's being multiplied with the A. So we do the opposite operation and we divide by A. So we divide by A on this side. We have to do it to both sides. And here we have the A canceling itself out, leaving us with T is equal to Vf minus Vi all over A. And you can see that these two guys just switched their places, but this is kind of the math behind it all. Okay, so T is equal to our final velocity minus our initial velocity divided by A, and we have the final velocity listed here at 8.33 kilometers per hour. Subtract away our initial velocity, 5.08, and all divided by our acceleration. So divided by 1170 kilometers per hour squared. Okay, so that leaves us with some calculating to do, and let's get out our calculator. Okay, let's tidy up the numerator here first. We'll go 8.33 minus 5.08 equals this, and then we divide it by our denominator. So then divided by 1170 equals 0.0027 repeated. 0.0027 repeated seconds. So not very long. Okay, now this, the question may be, where do I round this? Okay, so rules for significant figures will state we have to take the lowest significant figures within the numbers that were measured or given to us. So here we've got 3 significant figures, here we've got 3, and here we've got, well, there was 3 within the question. If we scroll back here, this was 1, 2, 3 significant figures as well. So our answer has to be 3 significant figures. So these guys here, these zeros, these are all like leading zeros. They don't count for significant figures. So what we end up doing is saying, okay, this has to be 2.77, and let me just erase the units out of the way here. This would have been 2.777 and so on. So where do we round this? Well, we need 3 significant figures. So let's round it at here's the first one, second one, third one. At this point here, we have to round it off. So this 7 is going to convert that 7 into an 8. So we have 0.00278 seconds is our time. Now, in scientific notation, that would look something like this. We have this decimal point that we're going to put right in here after the first significant figure. So we've got 2.78, and then we go times 10. Now, if it were here and we had to go back to where it originally came from, okay, that would be 3 places to the left, so we have to go minus 3. So 2.78 times 10 to the minus 3 seconds. Okay, so then a statement at the end, the time would be 2.78 times 10 to the negative third seconds. Something like this would be, doesn't have to be fancy, 2.78 times 10 to the negative third seconds. And that's a very small amount of time for that change in velocity to occur. Okay, and that time is very small because this acceleration value is really quite high. So we've got not much time at all to change from our velocity. Okay, hopefully that clears that one up.